Hi, welcome to this channel. So, this is all about NLP. This tutorial would be all about NLP. So, there would be series of sessions. This is the first class. In this first class, what we are going to do is we are going to see what is model, and how to interpret a model, and what are the different types of model. So, yeah, here, so let us give an example that why do we need a model. So, the model is required in order to get some answers. Everywhere we are using model. So, model, the term is used everywhere nowadays. So, why do we need a model? So, whenever we have some questions, whenever we are looking for answers, if you do not have anybody or anyone in front of you or nearby me to answer my questions, then we would be using computers to get answers. So, just assume that model is a kind of black box or your friend answering all your questions related to specific type. So, for an example, there is a model that is weather forecasting model. Then I can ask a questions related to the rain, whether it would be raining tomorrow or not, rain or no rain. So, here my questions would be whether it would be raining tomorrow or not. The answer would be either yes or no. So, these type of models are called as classification models. So, instead of just asking whether it would be raining tomorrow, we need to provide some information that those informations are called as the features. We can call this as x1, x2, x3. So, this x1 could be the wind speed, x2 might be the temperature, this could be the sunlight, next one would be humidity, x4. So, we need to tell this black box that this is all the parameters, all the informations, and tell me whether it is going to rain or not. So, then only it would give the answer. So, we need to give some information, and model would process those information and give us answers. So, we can assume that model is a kind of mapping function. It map all the x's and provide us answers to our questions. So, his mapping and then providing the value y. So, now can we call all type of this f of x as a model? The answer is yeah. So, before giving you the answer, I will give you some examples. So, for example, so if I am asking the question like what is the area of a rectangle? So, here my model is giving the area of the rectangle A. So, I am giving this model that rectangle length and width A and B. Now, this f of x will map this information A and B and provide the area of the rectangle. Is it possible to call this function f of x as a model? The answer is no. So, before giving you the reason, let me give you another example. So, there is another example where we want to know the shortest distance between these multiple cities. So, I am just providing this network. This is city A, B, C, D, E. So, all those cities are connected. Here, if I want to travel from A to D, what is the shortest distance? So, this is my question, and I am asking again this functional form, this mapping function, and this mapping function process this information and giving me the answer that go directly from A to D, this path. Maybe we can call this as a path 1, path 2, path 3, path 4, path 5, path 6, and it is giving me the answer that directly start from A and take the path 1 and D. This is the answer. And the third example is already we saw that what is will it rain tomorrow. And another example could be what would be the price of a house in this location. This is the mapping function. What type of information usually you would need to predict the housing price of a particular area or place. So, the house price depends on the size of the house, square feet of the house, and number of bedroom, and whether it has a swimming pool, whether it is a lawn, or and not only this information, it also needs the geographical location, zip code where it is, and it is a condo or individual house. All those information needs to be given to this model, and this will estimate the house price of the house, like maybe 70K or 1 million. Here, so I have given you 4 different examples. In the first example, it is for weather forecasting, and second example, it is just finding the area of the rectangle, and third one is finding the shortest distance, and fourth one is predicting that housing price. So, here the first one, this can be called as model, and fourth one can be called as model, but that's example 2 and 3 cannot be claimed as model. The reason is here this f of x, already we know this function that it is a into b, multiply these two and you will get the answer. So, here it is a kind of expression based on the input information, and we already know that absolute truth, what would be the answer. There is no ambiguity or no randomness here. Here also the same thing. Even though there are alternative way to reach the D, here there are some predefined set of algorithms to move from to find out the shortest distance. So, here the first one we can call this one as a equation or formula or mathematical expression. This cannot be claimed as a model. And the second one, this third example can be called as mathematical. This is so it is not a mathematical, we can call this as an algorithm. This algorithm will have the set of rules. The set of rules will give you an answer. So, so in all these examples, the first one, the first example, whether it is going to be raining tomorrow or not, in that example this functional form, there is no equation or there are no algorithm to find out that absolute truth. The truth would be either rain or no rain. So, even though we give that exact values, all the known values accurately x1 to xn, the function gives the probabilistic value for rain and no rain, because there are some uncertainty or probabilistics in nature. There are some randomness in this process. So, we cannot come up with that kind of algorithm or definite rule that we saw for example 2 and 3. Here we are modeling the process or modeling that given historical information. So, this process is called as modeling, and this function, mapping function, is called as model. And this is actually exactly same for the fourth example, finding out that house price. Even though we give the exact information like what is the square feet of the house, how many bedrooms are there, where is the location, but still there are ambiguity that one person may say it is $700, it depends on the demand and the purchase power. Maybe someone might have bought it for $750 or $800. So, this information is not cannot be accurately predicted. So, now we know the difference between model, mathematical expression or equation, and third one is algorithm. So, here in NLP class what we would be looking at is only the model. So, the classical example for mathematical expression equations are that kind of all theoretical equations, mathematical equations and algorithms, all kind of optimization algorithms. So, here in data science and machine learning, mostly some people they get confused with this algorithm and model. So, it is better to understand the difference. Then so how we create this mapping function. So, what is this mapping function and how we can interpret this mapping function f of x, and how we come up with that the absolute not the absolute value, the value y. So, here we give set of information x and it convert this f of x into y. So, here all our exercises on coming up with this functional form. So, in simple regression model it would be a simple linear equation like a1 of x, a2 of x2 plus a3. So, or we can call this as a theta 1, theta 2 and theta 3. So, here we can plug in this value x, the x vector x1, x2, x3. Here that value y can be calculated by finding out the accurate value for this parameters theta 1, theta 2, theta 3. So, in the entire modeling exercise, so we will be focusing on finding out what is these thetas are. So, we will see with details about this f of x in our next class. Thank you. Bye.